Welcome to springlib.
Okay, so we're given the following equation. V of x is equal to v sub a times 1 minus delta x over lambda raised to the n. We're asked to use the binomial theorem to show that this can be rewritten as in a different form, essentially. So what is the binomial theorem? Well, the form of the binomial theorem that we'd like to use is this. We have an equation or an expression of the form x plus y raised to the n. We can rewrite this as an infinite sum. N, choose 0 times x to the n times y to the 0 plus n, choose 1 x to the n minus 1 y to the 1, all right, plus n, choose 2 times x to the n minus 2 times y to the 2, and so on and so forth, infinitely. And we can write this in summation notation, but it's not entirely necessary. This form right here will allow us to rewrite what we've been given in terms that they want to see. Okay. So here, notice that x is 1 and y is negative delta x over lambda. But other than that, we can basically just follow this form, and we will end up with the sum almost that is exactly what they've presented, right? So also note that we have VA here, which we didn't discuss. This is not inside the parentheses here, right? So we can effectively just factor this out, right? Throw some parentheses around the whole thing, and we're good to go, which is good because that's what their form of the function looks like. Okay, so let's start then. If the binomial theorem is true, right, then v of x should be equal to, okay, then we factor out v sub a, open a big parenthesis there, and let's look at the first term. The first term, okay, is going to be n choose 0, right? That's just 1, okay, times x to the n. Well, x is 1, so that's just 1, so 1 times 1, and then y to the 0. Well, once again, that's just 1, right? Anything raised to the 0th power is 1. So our first term is just 1. Great. Okay, so then we can continue, and we say, okay, let's do the second term, okay? So what I'm saying is we've completed the first term, essentially, and we're moving on to the second one. Okay, now we're going to say n choose 1. Well, once again, n choose 1 is just n, okay? So we'll get n here, and x raised to the n minus 1. Again, this is always just going to be 1 because x is 1. X raised to anything is just going to be 1. And then we'll get the third piece of our term, which is y raised to the 1, which is just going to be y, right? So that's negative x, negative delta x over lambda raised to the 1. Okay, so note that basically because we have this y alternating being raised to odd and even powers, that's essentially the same as we can just ignore this negative and alternate between adding and subtracting our terms. So that's exactly what I'm going to do. I'm actually going to erase this negative here and these parentheses, right? And we're just going to say, okay, we're not adding n times a negative number. We're just going to subtract n times that number, okay? Minus n times delta x over lambda. Okay. Now we'll continue. Now we've got an even term, so we know this is going to be plus, right? Because we're squaring y, which is negative. And now we finally get an n choose 2 that means something, right? Right. It's no longer just meaningless, I guess, right? Because n choose 1 is just the number of ways that you can choose n things. So that's clearly just n. N choose 2, however, now it's the number of ways you can choose 2 things from among n options, right? So At this point, we're going to have to expand n choose 2 into its actual the actual formula for n choose 2, which is where you get n times n minus 1 over 2 factorial. And that's just directly, that's n choose 2. Okay, that's where that comes from. X is always just going to be whatever it's raised to, it's going to be 1, so we can just ignore x. And then y is just going to be our delta x over lambda, and it's squared. And I'm going to clean that up a little bit. That does not look very good. Delta x over lambda squared. Okay, then we'll get our third term. This one's going to be negative. Okay, again, here we have to expand and choose 3 now. You'll see it just increases each time. Okay, so n choose 3 is going to be n times n minus 1 times n minus 2 over 3 factorial. And then we'll get our x term is just 1, and then our y term is going to be delta x over lambda, now cubed. And then we'll add our next term and so on and so forth, and parentheses. And that's how, using the binomial theorem, we can convert this equation into the binomial expansion of that equation.